A and P1. That's why I have included here.
Because olfactory?
No, I see where you're headed with that, but it's not. It's not. Olfactory is purely smell, but as you imagine, there's some overlap as far as the interpretation of the taste. Facial, yes, facial nerve, absolutely correct. Does a sensation of taste. In fact, most of the tongue, the anterior 2/3 is the facial nerve. What other nerve might be associated with taste? Glossopharyngeal, that's number what? We can go through all 12 if you want. No, 9 it is. 9 it is, glossopharyngeal, okay, is number 9, okay? So we've got that. Be able to recognize at least one cranial nerve that transmits a sensation of taste. Makes for a nice fill in the blank, by the way. So be able to recognize one, okay? I'm sorry? Number 7. Facial nerve is number 7. Okay? All right, how about motor movement of tongue? Because we're going to move the bolus of food around, we have to have some nerve control over this, and that's going to be cranial nerve number... Yes, hypoglossal, she said that's number 12. Hypoglossal, okay? All right, and that's enough on the tongue, okay? Yes, I enjoy special senses as much as the next person, but we can't spend a lot of time on the transmission of these impulses up to the brain because we have to get into digestion. Nonetheless, here we can appreciate our papillae, where our taste cells are sitting, and as we look here, I've got most of the important information highlighted in red. We can see fungiform and filiform noted here. Fungiform are most abundant right in the dorsal aspect of the tongue, look like little mushrooms, right? And then the filiform, those are papillae that do not have any taste cells in them. Okay, that's the big deal with this. There aren't any taste cells in the filiform. Okay, what are they good for then? Would you think? Friction. They're good for friction, and they're very good at moving the bolus of food around in our mouth. That's what they're associated with. Okay. No, and that's it. No taste buds in there. So circle that one so you don't miss that one. And the other ones are foliate, which are difficult to appreciate, but they're on the lateral sides of the tongue, way on the back. You almost can't see them unless you could pull your tongue out, but you can't because you have these little reins, little frenula, right, that hold your tongue in. Or you're going to cut it though, like Gene Simmons probably did, right? You can pull it out. But anyway, you got that. And the circumvallae, which are pretty good, pretty gigantic structures, and that really is about the number. They're about 9 to 12 or so. That's only extra because you're probably thinking, the artist, why didn't he hold around a whole bunch of them? Okay, they are pretty scanty anyway, about 9 to 11, but those are the circumvallae. And each one of those do possess tasting cells that detect every type of tasting, whether it's sweet, sour, salty, bitter, or umami. And the old saying where you can taste certain substances on certain parts of the tongue more so actually is not the case. It's been shown not to be the case where you taste sour on the sides and bitter in the back. That's not the case. You do taste all of these substances all over the place on the tongue. So that's a little extra, but at least I kind of want to clear that up from what you may have heard. All right, so let's get to our rest of the oral cavity here. Pharynx, we know the pharynx, of course, is what does pharynx mean? Pharynx is throat. It's pharynx, right? And we have different parts to it. We have a naso. This is nasopharynx, as you might suspect, right? Oropharynx, right? And then we go down here to laryngopharynx, right there. We have our nasopharynx, all this area here. Oro, as we get into here, and then laryngo, as we get down to here. Okay. And so, would you guess that we have different types of epithelium as we go from oro or nasal to oro to laryngo? Yeah, if we're in this area, what would you expect the epithelium to be? Like respiratory epithelium? Yeah? Nobody knows? Yes, that would be the case. You'd find it. As you get into oropharynx, what would you expect the epithelium to be? Would it be respiratory or would it be stratified squamous? Stratified squamous, and also holds true as you get down to the laryngopharynx. Structure governs function for that, okay? And with the pharynx, what's the big deal as far as the muscles go? And that includes part of the esophagus here. What the muscles, they were those constrictor muscles, weren't they? I said that before, constrictor muscles that when they contract, they squeeze the bolus of food down through the laryngopharynx into the esophagus. Constrictor muscles, that makes sense because they're squeezing and then moving it down. All right, and esophagus, we've done histology already as far as the muscle features go, right? stratified squamous in there, and it is with. And there's a picture of our stratified squamous and all of that. What do you think these could be right here? I know you don't see them very well, but there's one there, here, here. Those are glands. Those are glands producing mucus. That's what they are. Okay. So far, so good? Histology all right? All right, let's do some stomach anatomy here, and then we'll get into histology of the stomach, because we have an interest, of course, of the cells and what their product is, and that's really, really important. So a little bit about the anatomy of the stomach so that we can have an idea of what we're talking about here. Esophagus meets the stomach right there. That's called the cardiac part, cardiac region. And if I'm going fast, that's okay, because we will see this in lab as well. So don't sweat if you're not getting all this right now, but I want to give you an introduction of this, because if I just start talking about this, you wouldn't have an idea of where it comes from. So kind of just sit tight and don't think that we're not going to come back to this, but we are. Okay. So we have the cardiac part. This is the fundus right here. Kind of this upward area here is the fundus. Then we have curvatures. Greater curvature, all that, greater curvature, and lesser curvature there. All right. Now, who went to the cadaver lab? Right. We had this big fatty apron hanging off the greater curvature of the stomach. What was that called? Greater omentum. Very good. Okay, so that hangs off. Do you think there would be a omentum right here? It's called lesser, right? And a lot of you cut through that in order to see the hepatic portal vein in the cat, right? Okay, so there's our curvature. We now also have a constricted portion here called the antrum, right? This is the antrum there. Sometimes even called the pyloric part. You can call it whichever one you want. Antrum or pyloric part is a constricted portion, okay? You also can appreciate here the muscles in the stomach, smooth muscles. They go in all different directions. They're transverse, they're circular, there's longitudinal, okay? And so, of course, what would you say that the function of these muscles would be? Churning, mixing? Yeah, churning and mixing. We're mixing now our bolus of food with the chyme, right? With the gastric juice, which we then call chyme. That's what that is. So we've got our bolus of food, we've got gastric juice, mix it together, we have chyme. What's the pH of chyme? Approximately 1 to 2. Very good. So I'll ask that several times as we go through. And we also see the rugae. That's the rugae that you can appreciate there. You'll notice that in your cat and get the cats back out for one last section. You'll see them there. Okay? All right. So we know the function of the stomach is what? Primarily to do, but it does other things. So what's primarily it is good for? Storage, yes, it's a holding tank for food, but we also know now it's good for mixing our gastric juice with our bolus of food, and we have that called chyme. What about any enzymatic breakdown? Enzymes in here, perhaps? What do you think? That's a big question. Any idea what foodstuffs can be broken down in here? Is it going to be carbohydrate? Is it going to be protein? Or is it going to be fat? Primarily, it's going to be what? Protein. Okay, primarily protein. So we're going to need an enzyme that starts to break down protein, because in the oral cavity, nothing happened. When I told you, hey, put a peanut in your mouth, what is it? Still a peanut after 5 minutes, right? Nothing happened. Okay, that wasn't the case with carbohydrate, and it was pretty much the case with fat, but there was some changes because of lingual lipase. But we go to protein now. This is one of the major functions of the stomach, besides being a holding tank, is the function as an area where protein breakdown chemically starts. So we need now an enzyme that starts to break down proteins, and it's called pepsin. Okay, pepsin. We don't know yet where it's coming from, but we'll get to that, right? And how it's made. But pepsin, okay, is a chemical that's going to be used for protein breakdown, cleaving proteins into what? Dipeptides, tripeptides, and even amino acids in some cases, okay? But that's where protein is going to start, with pepsin, okay? All right. You think there's also going to be a little bit of this? Maybe you do or don't. Gastric lipase. There's a little bit of that as well. Not overly effective. It's more effective rather than what you see in the oral cavity, but it definitely needs some work, because that's not very effective, at least in the stomach. We have to have another lipase coming along. Any guesses where another lipase will come along as we continue on here? Where could another lipase come from? Very, very important organ. Posterior to the stomach. It is the pancreas. Yes, and you might even call it what? What lipase? And granic lipase, yes, very, very important. All right, so we've got the function, the parts at least identified there, and so we can now look from microscopic presentation here. This is a light microscopic view, and we can see that the stomach has in it what are known as gastric pits. All these are pits, okay? We have the mucosa thrown into folds, but if you zoom in at a higher power, you'll see we have pits here, okay? Gastric pits. And all of these pits are formed by these structures here, which are gastric glands. So as you descend this gastric gland, you're in a gastric pit, and of course we're going to find various cell types in there, and we figure out what these cells are and what their product is too, okay? And there's our parts there of our structures that you already know. Pyloric part or antrum, whichever one you wish. All right, so histology of the stomach, we have an idea. Gastric pits is what we know already, and we have our cells here. So if we look at a gastric gland, right at the top, you find this mucosa, or rather mucus cells that produce mucus. It's not as viscous as the mucus that you're going to find in the GI tract, but in the small intestine and colon. But it is mucus that does seem to protect the lining of the stomach, although it's not overly viscous, but it still does help protect the lining of the stomach mucosa from this HCl, right? Okay, probably no surprise. Parietal cells, they have several functions. Parietal cells, you will not have to identify parietal cells histologically, okay? Don't worry about that. But you have to be aware of what the products are. One of which is what? HCl, hydrochloric acid. HCl. Would you think that this cell is going to be able to produce HCl within its cytoplasm and have it at the ready and say, hey, I'm going to be told to secrete HCl by some other chemicals that I'm coming to, and when it gets to me, I'm going to secrete HCl? You think that's a good idea for that cell to have HCl kind of prepackaged inside of it, or you think that would be very bad if you could have that in there? Actually, that's very bad. A cell is not going to have HCl, okay, within its cytoplasm, right? As we'll see maybe tomorrow, not maybe, we'll see tomorrow, we'll come across something known as a proton pump, okay, which will be pumping out hydrogen ion into the lumen of our gastric gland, and we'll also find in there in the lumen is chloride, and then those joined together will make our HCl, all right? So, just as an aside, okay, would you also think that if this cell is producing HCl, pumping